Hello, everyone, and welcome to the 2022 Nammour Symposium. I want to thank everyone here for coming and for showing up today. My name is Garrett Merriam. I'm an associate professor of philosophy, and I'm co-hosting here today with Professor John Park. I want to give you some quick rundown of how we're expecting things to go. But first, before I do that, I want to say thank you to everyone involved in putting this together. As you may know, the Nammour Symposium is part of the liberal arts week-long Festival of the Arts. And this is a lot of work goes into this across the board, not just for the Nammour, but for everything. So particular gratitude, of course, to Dean Sherry Meyer and to Aaron Mahoney, Dean Meyer's executive assistant. They've given us a lot of assistance, and we are very, very grateful for that. And of course, we're also exceptionally grateful to Kelly Smith and Carlos Marisol, our guest speakers today, who are going to be talking to us about the philosophy of astrobiology. So with the thank yous out of the way, let me give a quick rundown of how we want this to work logistically. Professor Kelly Smith is going to be speaking first. Professor Park will be introducing Kelly in just a moment here. Kelly's going to talk for about 40 minutes with the idea we'll have about 15, 20 minutes of a Q&A time afterwards. So if you have questions as things go along, please put them in the chat. I will be looking through, fielding the questions, and then handing them off to John, who will be running the Q&A with Professor Smith. And then at 11 o'clock, we will do the same thing with Professor Marisol. So without further ado, I want to hand things over to my co-host, John Park, to introduce our first speaker.
Great, thanks, Garrett. So I'll be introducing Professor Kelly Smith. He is Professor of Philosophy and Biological Sciences at Clemson University. He's editor of the Oxford University Press book, Social and Conceptual Issues in Astrobiology. He's widely published in journal articles in journals such as Synthase, Astrobiology, Space Policy, and Biology and Philosophy. And with that, I will hand it off to Kelly Smith.
Well, thanks to everybody, the organizers and the deans that gave us the money that made this happen. I appreciate being invited to this. I'm sorry I couldn't be there in person, although it sounds like the weather there is about what it is in South Carolina. So that's a little bit of a sop to my conscience. So let me start by saying a little bit about myself. I'm a philosopher of biology and also trained as an evolutionary biologist. So my approach to this is highly interdisciplinary. I'm not really an ethicist, though I've done a lot of work in applied ethics. As John said, I've written a lot about social and ethical issues in astrobiology and space exploration. That's pretty much all I've been doing for the last 15 years or so. I'm currently working on an introduction where I try to do kind of what I'm going to do in this talk, but in a much more systematic way. I'm going to do that with Oxford in the next couple of years. So the idea there is to try to produce a book that's an entree for people who are interested in getting involved, but they don't quite know where to start. Basically, I'm trying to jumpstart a new academic discipline of humanists and social scientists who are looking at these questions in space research. And my basic attitude about space, some of you might disagree after this presentation, but I consider myself a thoughtful optimist about space. I tend to believe that we should be going into space, but that doesn't necessarily mean that we should be going into space without having thought it through first. Okay, so the plan for this talk, I don't really quite know who all is in the audience. So I'm going to assume that there's a bunch of people who are mildly interested in the topic, but they don't really know a whole lot about astrobiology or some of the more recent developments. So I'm just going to sort of give a very general overview of some interesting issues and questions. And on a couple of those, I'll pause and make more of an argument. But in general, I think I'll just sort of strew a bunch of breadcrumbs out there. And hopefully what will happen is that as people listen to me talk, they get annoyed or interested in something and they jot down a question, and you can put that in the chat or you can wait till the end. Like Garrett said, I'm going to try to take about 40 minutes. It depends on how excited I get and how much I wave my hands and elaborate, but probably take about 40 minutes, give or take, and then we'll have plenty of time for questions. So, and I'll also just say that if you really get interested in this stuff and you want to continue to argue or discuss it, you're welcome to contact me by email, and I'll give you my email at the very end. Okay, so the first question I think that needs to be addressed is, basically what are humanities types doing getting involved in these kinds of conversations. I think that the simplest answer to that kind of question is that the bottom line is right now, the field is dominated by space science folks, and then to a lesser extent, businessmen and politicians. And so if the humanities and social scientists don't get involved in thinking through some of these questions in more detail, then the other people will do it for us. And the problem with that is that initial actions are going to be taken in the next 10 or 15 years. They're going to set precedents. And if those precedents are problematic, it's going to be much more difficult to get rid of the precedent than to avoid it being set in the first place. So that's sort of a very general argument for why humanists and humanities types should get involved. I also like to make an argument with my philosophy colleagues that there's a really good pragmatic bet hedge here. NASA predicts that we will likely discover evidence of life beyond Earth within the next 20 years. And I'll give you some reasons for thinking that in a second. We can argue about how likely that is to pan out, but if it does pan out, it will be probably the single greatest scientific discovery of all time. It's going to fundamentally alter how we see ourselves, and in particular, how we see ourselves in the universe. It's going to be on a par with the Darwinian revolution. And I submit that if that comes about, everyone and their cousin is going to want to get involved in this. And so it's actually not a bad idea, I think, for people now to be thinking a bit about putting a toe in the water. I wouldn't recommend that someone make this their life's work unless they have tenure. But it's not a bad idea to get a publication or two out there. So if we do discover life, you have some credibility making the claim that this is one of your areas. And I'm happy to help in that regard any way I can. And I'll just finally end by saying, I think there's room for everything. I mean, one of the nice things about being an early adopter is that the field is relatively open. There's more and more work being done here, but there's still a lot of sort of basic framework kind of work that hasn't been done. And by way of example, this last summer, I did a project with several undergraduates from Clemson and the University of Texas, as well as some high school kids from the Governor's School of Science and Mathematics. And we actually developed a series of case studies dealing with some of these social and ethical questions, and that hopefully will be published soon in Teaching Ethics. So that there are opportunities here for undergraduates to get involved. You just have to find the right people to get involved with. Okay, so we're used to talking about the space age, and when people talk about the space age, they normally have in mind, the Apollo era, so the 60s and 70s when we went to the moon. In some ways, that was a bit of a false dawn, because as we all know now, we went to the moon, we did some great things, and then everybody kind of yawned and they turned off their TV sets. And then we sort of launched a long period of unmanned missions, and a lot of people got uninterested in what we were doing. What we have now, I think, constitutes a true dawn of a true space age. The problem is that most people aren't following these developments well enough to really quite realize how far we've come. So I'll just throw out some gee whiz stuff, right? China germinated the first plant on the moon recently. Israel's already accidentally dumped a bunch of tardigrades, these weird life forms that are incredibly difficult to kill. They dumped them on the moon by accident. Human probes have left the solar system with greetings from Earth. They're going really slow, but they have left the solar system. The Interstellar Beacon Project, which I will talk about later in a little bit more detail, has announced plans to begin beaming Wikipedia to thousands of potentially inhabited solar systems beyond our own. And the Starshot mission, which is funded by a Russian billionaire, is currently doing a lot of things, one of which is developing a deep space microprobe that they'll actually be able to launch as a fleet of thousands to Alpha Centauri, probably within the next 20 years. Now, it'll be a while before we hear back from them, but they'll be able to fly through the system and image any planets in the system and send that data back to Earth. So this is not your grandfather's space age. Here's a couple more gee whiz things. Just last week, SpaceX launched the first corporate manned mission, and they're going to be basically constructing a corporate space station in Earth orbit. Space tourism is already a thing, so if you have $20 million, I think is the going rate, you can go up into space and experience weightlessness and have a great story to tell your friends. Several countries, the US, Japan, and Luxembourg in particular, have altered their property laws and their business laws to make them more friendly to space mining companies. So they're thinking that space mining is going to be a thing. They want companies to incorporate in their country so they can get the tax revenues. And so that already tells you that serious people are taking this very seriously. Manned mission to Mars, probably going to go off in the 2030s, already preparing for that. The James Webb Space Telescope was just launched recently and looks like it's going to shape up very well. That and other telescopes being planned are going to actually allow us to image the atmospheres of planets outside our solar system and chemically analyze their contents, which is a big deal. And then there are missions on the drawing boards for things like missions to Europa, which is one of the icy moons of Jupiter and may have liquid oceans that contain complex life. So all that is either happening or it's on the drawing boards and will happen in the lifetimes of many of the people who are listening to this talk. Okay, so my view is that if we're not very careful, we're going to get a Wild West period in space. In fact, I'm not sure that we can avoid it at this point, but it's definitely a concern. There are basically no laws governing most of what goes on in space. The Outer Space Treaty and the Moon Treaty are the two main documents that people put forward as the basis for space law. You can read both of those in less than an hour, and they're highly idealistic. They're basically written in the 60s when the assumption was that the only people doing this would be national governments, and they would only be doing it for the collective benefit of mankind. But the private enterprise activity in space has shown that that's an outdated model. NASA just recently put out the Artemis Accords, which update these to some extent, but still, space law is basically wide open. And so I also tell space lawyers that this is a good area to get into. The profit potential in space can't really be overstated. A lot of times it's said that the first trillionaire Earth sees will make their fortune in space, which not coincidentally is why so many billionaires on Earth, I think, are investing in space, because they're billionaires, but they would really like to be trillionaires. And they think the best bet to do that is to put some of their money into space right now so that they can be in on the ground floor of this new thing. Several countries are already actively exploring settlements on other worlds, not just the United States, but China and even the OAE. I think Israel's had some discussions about this. So it's getting to the point where lots of people are going to be empowered to do this, whether they're national actors or private companies. The costs are coming down, et cetera, et cetera. So to my way of thinking about this, human beings are going to be going into space, and we're going to be doing all kinds of things in space in the next 20, 30, 40 years. The real question is not whether that should happen, it's how it should happen. And then more specifically, what can we do to try to shape the decision-making for the better? So, there is always this conversation that people like to have about why we should be doing space stuff at all. It's very expensive, et cetera, et cetera. So I'm just going to run down the basic 4 arguments that you can give for this kind of stuff. First of all, obviously, there's all kinds of science in space. And if you don't care about rocks on Mars, then you probably do at least care about alien life forms. It's entirely possible that there's alien life within our solar system, maybe on Mars, even more likely on a place like Europa. And the current mission guidelines that NASA and the Europeans and others use basically lay out preserving the science as the primary consideration. So when they talk about the need to protect alien life, it's mostly in the context of protecting life so we can study it. You don't really want to land on another planet, contaminate all the indigenous life, and then not have a study organism later on. There haven't been too many conversations, at least in the space mission directorates, about things like the intrinsic value of life, which I'll talk about more in a bit. There's raw materials and money to be made out there. There was an asteroid recently discovered called Psyche 16, which is estimated to have $10,000 quadrillion worth of metals on it. Now, that's a weird figure, because if we were to actually harvest the metals off of Psyche 16, all the markets in metals on Earth would collapse. And so it wouldn't be really worth 10,000 quadrillion dollars, but it gives you some idea of how much stuff we're talking about. There's also been recent discoveries that the moon contains a pretty substantial amount of water. And so one of the missions of a lunar settlement would probably be mining the water on the moon and converting it into rocket fuel so that we have a very cheap filling station that's already up there in space. It would make missions in space a lot cheaper. Of course, it would get rid of the water on the moon too, which is another issue. There's the whole vision thing, mankind needs something to strive for, and space is this open frontier. Frederick Turner has this frontier hypothesis about America's personality being formed during the frontier era when we were exploring the West. That's highly controversial. It's been criticized by lots of people, but there's a story to be told about how West is, or the space is actually the final frontier and all that good stuff. And there are some interesting studies of this kind of thing. There's something called the overview effect, which is that when people go into orbit and they look down and see the Earth from orbit, and they can see the curvature, and they understand that it's basically a bright blue marble in space with a very thin atmosphere, and everything they know and care about is on that one little marble. Oftentimes they have what you might describe as sort of a quasi-religious experience, and they take this vision as sort of fueling a new way of thinking about humanity's role in the universe. And the most recent example of this is William Shatner, the guy who played Captain Kirk on the original Star Trek. He recently did the space tourism thing and went up there. And when he came down and they stuck a microphone in his face, he sort of waxed philosophical about how amazing it was and how awesome it was. And you can watch that video online. It's kind of interesting. And then finally, there's sort of the far-reaching question of constructing a second Earth, constructing a backup Earth in case something happens to this Earth. There are lots and lots of things that might kill off life on Earth, or at least set humans back, to the Stone Age. Take your pick: asteroids, gray goo from nanotechnology, bioweapons, whatever. There are lots of things that could happen. And so, all else being equal, it would be nice to have humanity sort of backed up in other locations. So if something happens to Earth, we can continue to exist. And one of the interesting things about when you start talking about existential threats to Earth is that they're all low probability events, and human beings are just notoriously bad at dealing with low probability events. And we're also notoriously bad at dealing with existential threats, although we don't handle them very often. Basically, human psychology is just not evolved to deal with very low probability existential threats. And so one question would be whether or not we really need to think through a new mechanism for addressing these problems now that we have a series of these low probability existential threats that we probably should be taking more seriously than we are. Okay, but of course, all this is complicated. It's easy to lay out the questions and then you immediately get bogged down in a whole series of complicated questions. So yes, science is very important and we all support scientific investigation, but part of the reason we do that is because we feel that scientific investigation really doesn't have much of a cost associated with it. But there are going to be trade-offs as we continue to explore the solar system. So for example, I mentioned Europa, one of the icy moons of Jupiter. We think that it's got sub-ice oceans that are underneath the several kilometers of ice. And we also believe that there's probably geothermal heating in these oceans, which is essentially the same sorts of conditions that we think prevailed on primordial Earth and may have given rise to life here. So it seems like a really good place to look for life. The problem is that you're not going to be able to do that without drilling a hole through several kilometers of ice and then inserting a probe. And that probe will necessarily be contaminated with terrestrial microbes. It's really not possible to completely sterilize anything that humans produce. So, when NASA says something sterile, what they're actually referring to is a standard such that there's fewer than one microbe per 200 cubic meters of surface area, something like that. So, we're going to have to decide maybe at some point, do we want to explore what might be a complex ecosystem in the European oceans, or do we want to avoid any risk of possibly contaminating that? When you talk about resources, you bring up all kinds of questions about how these resources should be distributed. Should we have private ownership? If we do, who should own these things? Are we going to allow only rich corporations and rich nation states to go out there and grab up all the good stuff because they have space flight right now? Or are we going to find some way to allow poor individuals and countries to play part of the game? There's also some really interesting questions about like non-destructive use of space resources. So for example, advertising on the moon. People have proposed that we could advertise on the moon right now using lasers, or we could put reflective materials on the moon. And I'll have a slide about that next that I'll show you in a second. The vision thing, one pessimistic thing you can say when people talk about manifest destiny and final frontiers and all that is that sounds like an excuse to do the kinds of horrible stuff that we've done in the past without really thinking it through very carefully. Colonization, after all, didn't work out so well on Earth. And a second true Earth, if we really want to talk about backup of Earth, then that's a long way off, a very, very long way off. You're talking about something like terraforming Mars, which we believe we have the technology to pull off, but it would be probably 1,000-year project and require really, really significant investments. And there are questions about whether or not humanity is even able to pull that off at our present state of development. Not so much that it's technically problematic, but just the socio-political organization necessary to carry off a project like that may not actually exist. And if it does, it may not be worth the expense, right? And of course, in the more immediate future, if everybody and their cousin is going to want to set up settlements on other worlds, then there are all kinds of questions about how exactly those should be governed. So when SpaceX sets up an orbiting space station around the Earth, that will be in low Earth orbit, and it will not fall under any earthly legal jurisdictions other than perhaps the country that assembled the modules. And if it's assembled by a private company, there may not be any legal framework whatsoever for that. Or the Chinese might set up a settlement on Mars and run it as an authoritarian state. There are all kinds of good reasons why you might expect authoritarianism to work better in space than democracy, but I won't go into that right now. So there's all kinds of questions there. This is just kind of fun. This is a piece of artwork that I did a couple of years ago. I'm also an undergraduate art student. And one of the things I want to do with art is try to use it as a way to introduce both the space scientists and the general public to some of these more complex issues that are arising. And a lot of times a picture can do that way more quickly. So I call this global marketing, and it's basically just a picture of the Nike swoosh superimposed on the moon's surface. And like I say, this is technically possible to do right now if we really wanted to. Arguments against space exploration. Well, there are a lot of arguments against particular kinds of proposals, but if you're just talking about, we shouldn't be going into space as aggressively as we seem to want to do. I think a lot of times the divide here between the enthusiasts and the detractors, it boils down to whether you're a pessimist or an optimist, right? And there's also some weird self-selection. So ethicists in general and environmental ethicists in particular tend to be self-selected to find problems with development. And space enthusiasts tend to be self-selected to be in favor of development. So to some extent, both sides have blind spots. But there's a very strong sentiment amongst academics in particular that we shouldn't go into space until we can solve the problems of Earth. I can't tell you how many times I've heard that. And you're welcome to ask me that if you want to. My response to that is that that's basically a reductio, because problems are a relative term. There will always be problems on Earth. There will always be poor people on Earth, because those are relative terms. And so if all you say is we shouldn't go into Earth until we solve, we shouldn't go into space until we solve the problems on Earth, then you're never going to go into space because there will always be problems on Earth, right? And my friend Laurie Moreno basically argues that, maybe space is okay in a general sense, but not for humans, because we've already demonstrated how horrible and awful we are. And she has a really interesting analogy where she said, if you hire a babysitter and the babysitter comes in and destroys your house, would you hire the same babysitter when you move to a new house? Probably not. And so human beings have sort of trashed our current planet, and letting us go onto another planet and do the same thing would be highly irresponsible, and we shouldn't allow that kind of stuff. So this is all part of a more general dynamic. People get very idealistic when they talk about space. It's a blank canvas, and they can paint on it however they want to. So people very quickly start wheeling out very abstract theories about how, everything in space should be shared with everyone else, et cetera, hence the Outer Space Treaty and all that kind of stuff. So my pragmatic response, I'm a pragmatic academic, a pragmatic philosopher, which is not actually an oxymoron, although it might be close. People are going to go into space. There's nothing much that academics in particular can do about this. So we're better off to focus on trying to avoid some obvious kinds of problems and mitigate the kinds of enthusiasm that we see than to try to stop it. And if you're going to have a moratorium, you need to be clear about what would end that moratorium. And in particular, saying things like, well, when we come up with a viable alternative to capitalism, which allows for truly sustainable development, then we can go into space. That I find is pretty impractical, because that doesn't seem to be on the horizon. And lastly, I think this is an interesting point that almost nobody considers, that when you say we should stay on Earth, the assumption you're making is that everything we need to solve Earth's problems is on Earth, which is highly debatable, right? Having access to lots and lots of resources in space will make all kinds of things cheaper and more available to people who currently don't have them. Polluting industries that currently mess up inhabited areas on Earth could be moved off-world, and they would pollute perhaps the moon, but the moon is lifeless, so there's less at stake there. And finally, in space, there's likely, I think, to be a development of something like a super environmental ethic. You don't appreciate plants until you absolutely positively rely on the plants in the biopod to give you oxygen and food. And so it seems to me entirely possible that settlers on other worlds will have a much, much stronger environmental ethic than most people on Earth do now. And that could be imported back to Earth and have beneficial impacts. So I want to talk about METI just briefly. People have probably heard about SETI, the search for extraterrestrial intelligence. METI is about messaging extraterrestrial intelligence. And right now, just like a lot of things in this area, there are no legal restrictions of any kind. So anybody with access to a radio telescope or a powerful laser can beam whatever they want to into space with no restrictions. And this has been done at least 16 or 17 times. We don't actually have a list. The most egregious example is there's a private millionaire who is running the Interstellar Beacon Project, and he wants to beam Wikipedia to thousands of potentially inhabited worlds. Now, one of the catches is that the message is going to take a long time to arrive, hundreds or thousands of years, depending on where it is. And then it would take a long time for a return message to come back. And so one question is how much we should worry about this at all. I mean, you're talking about future generations way down the road. On the other hand, I think most people would allow that we probably should not, we should worry about it more than not at all. How much is open to debate. And things get strange when you talk about ETI, which is extraterrestrial intelligence, as opposed to extraterrestrial life. Any ETI we encounter is almost certainly going to be way, way more advanced than we are technologically. And that's just a probabilistic argument. Humankind has only been around for a very brief amount of time, and we've only been technological for an even smaller amount of time. So if there's another intelligence in the universe, it's almost certainly going to have evolved way before us, or be very primitive and not intelligent. So if we run across aliens that have space flight and can do radio telescopes and things like that, they're probably going to be millions of years more advanced than we are technologically. And one of the weird things that happens in the METI community is that people who want to send messages to other worlds tend to just assume that any hyper advanced technological species would also be advanced in a social and ethical sense. So they'd be beneficent and peaceful. And even if you think that's not a bad argument, it doesn't seem to be a slam dunk argument. And even the possibility that we're wrong about that should give people pause. And one of the reasons for that is that any signal we send from Earth to another world will definitely reveal two things. Whatever's in the signal, it will reveal that we're primitive because we're still using electromagnetic radiation, right? And it'll reveal where we live because the signal's directional, and an intelligence that intercepts it will be able to backtrack it to Earth and be able to identify the planet that we came from. How much you worry about that, I suppose, is kind of a personal decision, but it seems like it's a prima facie case for caution. And I think the more interesting question about things like METI, although this could be mirrored in a lot of these things, is who exactly should be deciding this and how? Right now, the decision is basically left to a bunch of scientists who run radio telescopes and lasers and things like that, and there's no supervision. But if there's risk, and I think there is, even if it's hard to quantify how high the risk is, it's a risk that all humanity shares. And therefore, one obvious position to take is, well, if it's a risk that all humanity shares, then all humanity should share in the decision about whether to do this. And, you know, there's a pragmatic question of how exactly you get humanity to weigh in, but it doesn't have to be a signed consent form. It doesn't have to be hard laws. You can have various kinds of representation where you have a discussion in the United Nations or whatever. But right now we've got nothing. And I don't think it takes much to argue that pretty much anything we did along these lines would beat nothing. So are we alone? So I've changed the background here. The resolution is not amazing, but some of you might recognize this. This is the deep field, NASA's Hubble's deep field study. Basically what they did is they took a segment of the night sky, a very small segment, about the size of a dime, held up at arm's length. And it was a segment that, as far as they could tell, there was nothing really interesting happening in. There was nothing really obvious in that segment that was interesting. And they focused the Hubble Space Telescope on it, which was our best at the time, for 10 days. And the Hubble collected every photon it could gather from this little spot of the sky for 10 days. And it produced this image. Almost every single dot you see in this image is a galaxy. There's about 10,000 of them in this one image of this uninteresting piece of sky. And each one of those galaxies has ballpark 100 billion stars. So the universe is a humongous place. And that is the basic genesis of the argument that we can't really be alone. There's fundamentally nothing mysterious about life. I'm an evolutionary biologist, so I'm contractually obligated to say that. But I mean, you know, life is something that happens if you have the right kinds of conditions and you wait long enough. And there's a famous equation called the Drake equation, which I give you here. I won't go into detail. Basically what it says is you take the number of stars you think are in the universe, and for each one, you multiply that by the probability that it's got a planet around it. And you multiply that by the probability the planet's habitable, and then by the probability that life evolves, and that by the probability that life becomes intelligent. And you eventually get a number that's supposed to represent the likelihood that we will one day make contact with another intelligent race. Now, you know, Drake was talking about SETI and METI kinds of things. It's easier to make that come out in your favor if you're only looking for life. But the bottom line is the universe is so enormous. And exoplanets, planets around other stars, are way more common than we thought they were just 15 years ago, that it's really kind of hard to do anything with the Drake equation and make it come out in the single digits, right? It's just very, very difficult. You have to make really implausible claims about things like the likelihood that life arose on a given planet. And the chemical components of life, we now know are basically everywhere, including in deep space. So even organic molecules can be found on comets and things like that. So, I mean, one sort of interesting question for the philosophers of science is, where exactly is the dividing line between doing science and being speculative? The Drake equation was put together by scientists who's trying to constrain a very complex question that we don't really have the data to answer in a definitive way. Is that just speculation, or is it science, or is it somewhere in between? And a whole lot of the questions, particularly in astrobiology, fall in that kind of gray area. They're speculative. Whether they're merely speculation is a matter of debate. Okay, I'm not going to talk about defining life a whole lot because I think that Carlos is going to talk about that next, although I'll just tell you that Carlos used to be reasonable and believed that we needed a definition of life, and I think he's fallen off the deep end and he's become part of the evil opposition. But I'll let him convince you that he's right about that. I personally argue that we really need to have at least a working definition of life, if for no other reason than if I'm a NASA scientist and I'm trying to design an experiment to put on a probe that detects life, I need to know what it is I'm looking for. And there's still debates about the Viking mission to Mars because the results, according to the original design, were positive for life. And then they've been reinterpreted. And part of the problem there is that we just don't really understand exactly what we think life is, and therefore what would constitute good evidence for life. I think given the time limits, I'm just going to sort of briefly talk about UFOs and UAPs because it's weird. One thing to say about them is that part of what drives the space science community is a need to distance themselves from UFO craziness, which is perfectly understandable in a way. But in another way, it's not really the kind of concern that science should be worried about, like in a sort of theoretical sense. And it raises questions about at what point does a weird hypothesis become scientifically respectable? So there's the recent Pentagon report about unidentified aerial phenomenon, which sort of suggests that there seem to be some things going on now that are reasonably well documented that we just can't explain. That doesn't necessarily mean that alien visitation is the best explanation. Even if you think these things are weird, in my personal view, the kinds of things that the Navy is talking about are probably best explained by a Chinese technological breakthrough, or maybe the CIA doing some kind of mind games on its opponents. But the Oumuamua object is another matter entirely. The Oumuamua object is this object that we recently detected coming into the solar system from outside, which is weird. It went around the sun and seems to have accelerated on the way out of the solar system. Now, I'm not an astrophysicist, so I'm not really qualified to debate this, but there's a guy at Harvard, Avi Loeb, who basically argues that we should be seriously entertaining the possibility that this is an alien probe, because the flight characteristics are pretty much what we'd expect of something like a light sail launched by an alien race who wants to come investigate our solar system. And there's some aspects of the object that are at least very difficult to explain based on the model of objects that we have currently in our astrophysics inventory. So it's an open question. I think most physicists don't think that it was an alien probe, but Avi seems to think it's a reasonable hypothesis, and he's been very annoyed by the, let's say, overwhelmingly negative reaction he's received. He basically argues that this is more about politics and not wanting to seem crazy than it is about doing objective science. So when we're talking about life out there, there's at least four basic possibilities. We find nothing, which would, I think, be a really interesting result all by itself. We find slime, which is by far the most likely. We find multicellular creatures, which is much less likely, but might be possible, say, on Europa. Or we find extraterrestrial intelligence, which is very unlikely anytime in the near future. And if we did, it's not really up to us how that plays out. In some sense, these can be dealt with by environmental ethics, but there are some weird twists that I think the environmental ethicists haven't fully wrapped their minds around. So one is any life we find out there is going to be part of a different ecosystem. So in environmental ethics right now, there are two basic sorts of arguments against destroying things. One is its intrinsic value, and the other is its instrumental value. And there's not always a clean distinction between those two, because anything on Earth we share an ecosystem with, So I might not want to destroy the rainforest, not because I care about trees per se, but because I like oxygen. But when we encounter life on another planet, there's not going to be any kind of instrumental consideration like that. There'll be scientific instrumental considerations, but there won't be anything else. So arguments about life on other planets are going to have to be based pretty much entirely on intrinsic value arguments, which are weird for reasons I won't go into right now. And while life on another planet would be unprecedented, it's also true that finding life on other planets suggests that life in the universe is actually quite common and maybe therefore not as special. So here's some ideas that I think are really quite stupid, but they make us feel good and they seem to be fairly popular. Carl Sagan said that if we find life on Mars, even if it's just microbial, we should leave Mars to the Martians. And Chris McKay upped the ante over this, which I didn't think was possible, but he did it by saying that if there's microbes living on Mars, they're hanging on by whatever their equivalent of a fingernail is. And so we should terraform Mars to make it a better place for the Martian microbes. Uh-oh. Whoop. Hold on. Okay, here we go. I'm almost done, by the way. So, I mean, I have an argument here that I'll just lay out fairly quickly, and then I'll turn it over to Q&A. If we assume that there are microbes on Mars, and let's assume that we've studied this life form for a while, 50 years or something like that, and we've answered most of the major scientific questions about it. And there's something that we can do on Mars that would be of real utility to humanity, whatever it is, whether it's mining or a second Earth, whatever it is. And it's feasible to pursue that opportunity. It's technically possible, but that doing so would have a negative impact on Martian microbes, right? Which, by the way, it seems to me this is quite likely to be the case if we do find life on Mars. The argument is basically pretty simple. Human beings have the highest known category of moral value. And so whatever else we have unambiguous moral obligations to serve human interests, particularly the interests of humanity in a collective sense, right? The claim that Martian microbes are of equal moral value to humans, it's not a crazy one, I suppose, but it's at least highly, highly debatable. And I actually have some data about what professional ethicists think about this, and they don't think too highly about it. And so the bottom line is, to the extent that we can't come up with some clever compromise and get what we want for humanity while also preserving the microbial life, then we're forced, if we have to choose which to maximize, we're morally obliged to err on the side of human interests. That's not politically correct, but I think it's absolutely true from a moral point of view. And that's pretty much my 40-minute spiel. I think I will just shut up now and let people ask me whatever questions they have, and we can talk about whatever interests you.
All right, Kelly, thanks for that interesting, fascinating, and thought-provoking talk. If you have questions, go ahead and shoot it in the Q&A. I know Garrett Merriam is on the edge here for wanting to ask a question. So I will let Garrett ask his question.
Okay, Kelly, thanks very much. I thought it was a really interesting talk. You touched on a lot of things I was hoping you were going to touch on, and in many ways stole questions out of my mouth before I had the chance to get to them, which to my mind is always a good sign of a good talk. Quickly before I ask my question, I want to say, as John said, if you have a question, you can put it in the chat and I will pass it off. John will either take it straight up or I'll pass it off to him to ask to Kelly. Alternatively, if you're really just dying to speak instead of to type, you can use the reaction function to raise your hand. I'll keep an eye on that too, and then I'll turn on your microphone so you can ask it in person if you'd prefer to do it that way. So Kelly, my question to you is, I want to push you a little bit harder on the what you might call the "we need to get our own house in order" first argument that you addressed. I think a lot of people in my social networks, at least, see the sort of the current space race with Bezos and so forth going on, and they have this just a visceral sense of injustice. And the way you phrased it was sort of in the abstract about, like, how can we ever sort of pinpoint a threshold when it would be justifiable to go into space? And I think that's a fair requirement for anyone who really wants to double down on this argument. But I think that there's a powerful place to start which is just, when you consider the fact that there's still hundreds of millions of people on this planet that are starving, that are homeless, to see them literally living in gutters, and as rockets fly overhead. I don't think you have to, be a Marxist or anything like that to feel just that incredible contrast between such extreme wealth and such extreme poverty is something that needs to be addressed, rather than just saying, well, it's inevitable, it's going to happen, so let's just try to manage it. You may be right that it's inevitable, but that doesn't mean that we don't need to justify that decision, the decision to spend such huge amounts of our limited resources to the human beings who are living off of so few of our resources. So I guess what I'm asking is, I want to push you to not just punt and say it's going to happen one way or the other, and ask you, do you think that it's justified? And if so, how is it justified to spend our resources in this way, given the existence of such extreme poverty?
Okay, well, obviously I can't completely answer the question, but I'll make a couple of points. So one is, I think in some sense it's a false dichotomy. So, I mean, it's not the case that if we pursue space exploration and this kind of thing, that we would not also be able to solve some of these other problems, right? Or one way of putting it is, why single out space exploration as the thing that gets terminated because of these issues? I mean, like, you could make an argument that you could do the same thing. You could cut back on military budgets, or you could reduce corporate welfare. I mean, there are all kinds of things you could do that would free up money to deal with these other problems. So in a way, I think it's unfair to blame space for this, particularly since space offers all kinds of opportunities that may make the world a better place in ways that are hard to articulate. So it's a bit of a false dichotomy. I don't really have an objection in principle if someone wants to argue that these problems on Earth are more important than the kinds of stuff we're doing in space, and because of these reasons, we should be focusing on those first. But very few people do that. What they do is they wave their hands and they say, well, there's all these problems on Earth, like people starving, and so we shouldn't be going into space. Well, that's not, it seems to me, a careful argument. You really need to get into the weeds, and you need to talk about, well, what sorts of problems are we talking about that must be resolved first on Earth? Tell me how they're going to be resolved and how much that's going to cost. Establish that we can't also do a space program while we're doing those at the same time. Then maybe we can have a debate about, who's right and who's wrong. But I think normally this kind of argument gets thrown out as sort of it's like a debate ender. It's like, I'm not even willing to get involved in the debate because obviously we should solve the problems on Earth first. And that I find just deeply annoying. It's not really intellectually defensible, it seems to me, to do something like that. And finally, I'll just say, I think it's a major and problematic assumption that we're going to have an easier time solving some of these problems on Earth only using the resources of Earth. Nobody really has thought that through carefully, but it's clearly an assumption that people make when they say we shouldn't go into space, but instead solve the problems of Earth. So there's my quick 2 cents.
All right, thank you very much.
All right, we have a question from the chat from Jacqueline. She's basically asking, if there was some kind of catastrophic event on Earth and we moved to a second Earth or something like that, and only the wealthy could do it, would there need to be some kind of distributive justice to help the poor and the middle class, some of them, to actually get there as well, or not?
I think it's a really good question. This is exactly the kind of question that people in the humanities and the social sciences should be working right now to think through, right? Let's just say there's really no legal obligation to do anything in space in one particular way versus another. So what's likely to happen is everybody and their cousin is going to do whatever suits their own interests. So, one of the cases that we have in the paper I alluded to that I wrote with the undergraduates is about a company that sets up a solar energy platform in low Earth orbit and brings in workers, and they run the platform according to their own corporate rules. And these rules are very, very worker unfriendly, but it does produce really cheap energy, right? How do you decide about something like that? Or how do you decide who gets to go on the spaceship to Mars? NASA and the European Space Agency have both recently launched a para-astronaut program, which is really interesting, where they're actually starting to try to find out, as opposed to just assume, what people with various kinds of disabilities can and can't do in space. And sometimes there's some interesting advantages, like for example, blind people would be far less affected by a power shortage in space, which is a very common situation because they don't need light to see. But you can make the same argument about poor people. You know, should poor people be allowed to sign up for astronaut programs? Or if poor people disproportionately sign up, is that sign of exploitation somehow? These are really complicated questions that we need to think through.
All right, and then next, Matt McCormick.
Hi, thanks. Can you hear me? I've got a lot of background noise, so I hope you can hear me. I wanted to just add a comment here that it sort of goes back to Garrett's first question and see what you think about this. But in lots of these reactions we have, especially when we say things like, well, we should get our own house in order, I think what lots of people are failing to do is make a distinction about what we mean by we. Because the major players here are nation states or very big private corporations like Elon Musk. So when we say we want space exploration to go X way or this way, or we think something else should happen before we do space, well, nation states have a track record here of being able to do some things. Democratic governments can't actually pull off very much, certainly not the American government. The cycle's got to take 4 years, and it's got to be low budget, and it's got to be a pretty modest project that NASA can pull off in a short time frame. They can't pull off any sort of large scale. They had 17 directors in the last 20 or 30 years, and they're all political appointments, so they can't pull off any sort of large scale projects. And their budget has been cut to a tiny fraction of a percent. So when we say we want space exploration to happen a certain way, well, we're not going to accomplish that through the American space program. So are we saying we want corporations to do certain things about this, or we want private individuals, billionaires like Elon Musk to do something? Well, that's a very different question. We're asking, or we're demanding that global poverty be solved, or that some global medical problems be solved, or whatever. Like, well, what is the general mechanism we have in place for taking care of global problems that we are demanding that billionaires take care of? Because what we're asking is, or what we're pointing out is that billionaires are going to spend their money on what they spend their money on, and we don't like what they spend their money on. Well, that's the way that works, unless you want to create or institute some kind of major national or global legal system that changes billionaires, right? And people aren't going to do that. So I think, it's not enough to for folks to complain or protest that we need to be doing other things before we move to space, when we're not sort of acknowledging where the obvious paths are here for any kind of pragmatic effect. I'll just leave it at that as more of a comment to see what people thought.
I think your point is very well taken, and sort of put a little bit of a twist on it. I think what we probably could control, I guess, is public spending on space. And so if people that really don't like space exploration and the money that's wasted on that, they could perhaps shut down NASA, right? But if we do that, then what will happen is the Bezoses and the rich billionaires of the world will invest in space entirely on their own, and they will come up with space infrastructure and things like that. And then later on, if anybody else wants to get involved in space, they'll be in the position of having to purchase access to this private network of stuff, which might be way worse than a hybrid system. So it's one of those careful what you ask for situations. Like, before we start making these pronouncements, I would like someone to have really thought through very carefully what the various ways in which the development can work might be, and what the advantages and disadvantages are. And typically, like I say, this kind of argument is put forward as a conversation stopper rather than the entree to a very complex, nuanced discussion about political systems or whatever, right?
Okay, we have a question from Maddie here. When do you think the average person, like let's say a middle-class person, will have access to space exploration and space travel?
It's really hard to predict the pace of technology, right? I mean, like, lots of people have gone bankrupt trying to do that. So, I would say, you're talking about a middle-class person being able to go to another world as opposed to just like hop into outer space briefly and come back. that's probably at least 50 years down the road. And it might be longer than that. The first settlements on Mars, say, are going to be grim affairs. They're going to be not that big, not that self-sustaining, not places where you'd want to go raise your family. And it will be a while, probably a long while, before you have something like what we would think of as a city on Mars that's more or less self-sustaining, and you could raise kids and go to college. But it might happen faster than we think, particularly if people find ways to make trillions of dollars in space. Trillions of dollars will make everything go way faster. And so it's hard to say for sure, but unfortunately, probably nobody in this audience is going to be able to get a reasonably priced ticket to Mars. That's just probably not going to happen.
Okay, and we have a question in regards to, well, maybe there might be an issue that we need to resolve first here on Earth before maybe discovering aliens or something like that. Maybe we need to solve problems about racism and sexism just so that when we possibly meet aliens, we're not going to be xenophobic.
Well, yeah, the question of how we would react to aliens is a really interesting psychological or psychosocial question. It's hard for me to think about what it would look like to defeat racism. So it's hard to know how such a victory would impact our attitude towards aliens. But again, my basic orientation would be to say, that's a massive long-term social project that we've been working on for thousands of years. And if you're going to imply that we shouldn't try to make contact with aliens or explore space until we resolve that, I think that's just a recipe for not doing anything in space. And all I would say about that is there is a cost to that as well. It's an opportunity cost, but there is a cost to humanity of foregoing the development of space. And that needs to be explicitly weighed against, whatever advantage you think there might accrue from getting rid of racism first, and have to consider how long that's going to take and all that kind of stuff. So.
Okay, and then we have Hassan. You have your hand up. Would you like to speak, ask a question?
Yeah, I was just asking the probability of finding, I'm not sure if you can answer this, Kelly, but the probability of finding non-carbon-based life forms, if there's any actual scientific backing that's even possible.
Well, I'll answer that question with a brief but illustrative story. So I went to a session that the National Academy of Science did, and I was like the token weird philosopher guy. And we divided up into teams. There was a team that was going to talk about what life as we know it would look like on another planet, and then there was teams that talked about in situ observation and remote observation. And because I was a weird guy, I got stuck on the team that was thinking about what we could learn remotely, like using telescopes, about life as we don't know it on another planet. And we all talked about that for maybe 5 minutes and decided that there was really nothing that we could say about that. Like, if it's life as we don't know it, we don't really know what that would look like. We can speculate, and I think there's a decent argument to be made that the kinds of biochemistry that we're familiar with is likely to be a sweet spot for life, so that much life in the universe, maybe most life in the universe, is biochemically similar to ours. But it's easy to speculate. There's been a bit of a debate recently about whether or not it's possible for life to exist in the atmosphere of Jupiter, which is a weird environment, but it's not clear that it's not possible. It might not be very likely, but it's not clear that it's actually impossible. So the honest answer is we really don't know. We don't know.
Okay, and the last question for our speaker is, given that the high probability there is for alien life, how come we have not come into contact with life yet?
Well, the universe is a very big place, which means that there's likely life there, but it also means that if there is life there, it's going to be hard to find. It's a bit like what some oceanographers often point out, that we think we understand the oceans really well, and we've lived with them for thousands of years, and scientists have studied them for hundreds of years. But, you know, all you got to do is put a net out behind a ship and you troll the water, and then you analyze the DNA that comes back. And what you find is that 90% of the DNA comes from life forms that we're not familiar with. And that's on Earth, in the ocean. So we've only explored a tiny, tiny fraction of space, and that includes the kinds of radio signals that we get. So it's very likely that there's life out there, even life that's actively trying to contact us that we haven't made contact with. It's hard to really estimate exactly what those odds are, but the fact that we haven't yet contacted life really doesn't tell us much about whether life is out there or whether it wants to contact us. But there's a whole, read the Fermi paradox if you want a whole cottage industry of analysis about why we haven't heard from life in other places.
All right, Kelly Smith, thank you very much for your very interesting talk. And
Thank you all.
definitely applause. And I will now introduce our next speaker. Next on board, we have Carlos Mariscal. He is Associate Professor of Philosophy at the University of Nevada, Reno. He works in areas like philosophy of science, astrobiology, and philosophy of biology. He's an editor of the Oxford University Press book, Social and Conceptual Issues in Astrobiology. He's widely published in journals such as Synthase and Astrobiology. And I'll just say that we were former grad students together, and maybe that's why subconsciously we both happen to be wearing the same outfit, possibly. So with that, I will give it up for Carlos.
We're both wearing Carolina blue instead of Duke blue. Oh my God! Thank you, John, and thank you, Kelly, for a great talk. I agree with most of what you said, all of the correct things, obviously, and disagree with the incorrect things. Thank you to Garrett and to everybody, and to all of you for being here. So my name is Carlos Mariscal. As John said, I am an associate professor. This is my second talk as a newly tenured associate professor. And I want to talk to you about this question, which I think hopefully will be of interest to some of you. And if not, I'll try to motivate it. When will we know if we've discovered alien life? So I'm a person that doesn't like surprises. I tell my students, when you write a paper, tell me what you're going to say, tell me that, and then tell me that you said it. So if you would like to follow along and just know what's going to come, you can download the slides on my website / this talk title. You can also download the paper, which is currently under review. I should probably not be hosting it online, but so it goes. Such is life. I don't want you to be surprised. I will eventually say this. What counts as evidence of extraterrestrial life depends on our concept of life itself. We cannot go explore willy-nilly and hope that the universe will just provide us things that we take for granted as this gets to be life. And to tell you why I think this matters outside of a philosophy of astrobiology, a philosophy of biology, or a philosophy of science framework, I think this applies to a lot of concepts. The issue that I'm going to discuss applies to things of which we have a single example. So you might think that we're the only intelligence. You might think that we're the only consciousness, that we're the only morally considerable persons. When we're talking about other possible cosmos, you might think that those are, what we can reason about that. You might think that we can have intelligent conversations about that. And I think that everything that I'm saying, you can just like substitute the word life with consciousness, with any of these like history, right? We have a single example of history. The entire cottage field in philosophy of counterfactuals, I think, is going to fall victim to some question, a problem that I'll raise here. But sort of as a prologue, I like, this is just scene setting. This is before the talk. I like asking this question, like, how weird do you think life could be? And so we might make up a completely arbitrary scale here, right? Decreasing similarity. If Emily Park were here, and I hope that she's doing well and recovering, she would probably question whether there's a single scale here, and I think she's right. But for our purposes, let's accept that you can have a scale of weirdness. Really close to humans, wearing the I guess the CSU Sacramento colors. We have Spock, right? So in some science fiction, we see very, very humanoid creatures, creatures that resemble life exactly as we know it. Maybe they have pointier ears and are a little bit less emotional, but maybe they have like putty on their nose or something. But they're basically humans as far as we know. And the reason for that is because a lot of science fiction isn't about plausible hypotheses for how life is elsewhere. It's really just telling stories about like 1960s America, or telling, helping create a world where you can assess our own reality by virtue of how things play out in this fictional world. When I was a kid, I used to read this book series where the author complained about Star Trek, saying that the only aliens that they encountered in Star Trek, with a couple of key exceptions, were basically humans with putty on their nose. And then she would describe these creatures that had many legs and many arms. And she said, well, who knows where their mouth could be, and who knows how many eyes they could have. And yet, nevertheless, like, it's still bilaterally symmetrical. They're still multicellular. It's still very similar to life on Earth, right? So it's not that far removed. There are people that work in this field that are interested in life elsewhere. And there's this particular book by Louis Irwin and Dirk Schultz-McCook where they go through all of the plausible objects in the solar system, from the moon, or sorry, the clouds of Venus to the moons of Jupiter. And they posit how life could have originated there if it had, and they even like construct interesting ecosystems. The entire field of origins of life study focuses on how weird life could have originated. There's people that think that maybe like boundaries aren't necessary for life. Like maybe the fact that we have skin that separates us from the world is just like a choice that we made. You could imagine hermit crab type situations where they're just hopping from little pockets to little pockets. People are thinking weirdly about how life could be. In a slightly different literature, some people talk about non-carbon-based humanoid, maybe artificial intelligence as being alive. And those are interesting discussions, I think, worth having. There's one of my favorite books is by Fred Hoyle. He's a famous astronomer who coined the term Big Bang, even though he didn't believe in it. The book is called The Black Cloud, and in it, humanity discovers that there's a sentient cloud that's about to gobble the sun, and so we make contact with it. And interestingly, the premise of this is we thought life was going to be like somewhere on the other end of this continuum, and then we discover a sentient cloud, and we realize life could be even weirder than we thought. We were convinced that it was alive because it was conscious, it could communicate, it had intentionality, all of those fine buzzwords from philosophy of mind. And so we overcame all of our Earth chauvinism, all of our focus on contemporary biochemistry or whatnot, to open up the criteria of life to this phenomenon. And I think people that argue that robots are alive are maybe making the same sort of move in some ways. And then lastly, the people that think that even rocks are alive, right? There's people that have argued, and I admit I've toyed with this before in the past. In my younger years, I considered, we could just dissolve this entire problem by just saying that life is everywhere. Everything is life. It kind of reminds me of this view in philosophy of mind, panpsychism, where you say, well, how does matter create consciousness? How does it create this lived experience? Maybe there just is that everywhere. What is it like to be a rock? It's not like much. How alive is a rock? It's alive-ish, but very little. So like you can think in this in terms of this scale of how widely we want to open the concept of life and how narrowly. And the spoilers, I don't think there's a principled place to stop here. I think that what's going to end up happening is we come to a practical agreement. We come to a consensus about what we consider relevant to life. In the article that I wrote for this for the Stanford Encyclopedia of Philosophy, if you just look up life, I wrote the most recent article on that. And I draw the analogy to death, right? In the 20th century, we developed new technologies that allowed people to persist longer than we thought. And so we had to figure out whether the brain stopping or the heart stopping or other parts stopping counted as death. And we just made a decision. We came to a consensus. So that's what I think we're going to have to do. So that was a very long prologue. I hope I've timed out the rest of the talk correctly. We're going to get into some of the meat, the philosophical meat here, and hopefully I'll be able to explain this in such a way that even undergrads that are not philosophy majors or minors or whatnot might be interested in. So I'm going to present a problem that is called the n=1 problem, a new version of that problem which I'm developing. And then we're going to talk about kinds of evidence and evidence of kinds, which is more than just like a cute way of talking about it. I think there's things to say about both. So the n=1 problem, n being a sample size. So life on Earth is our only example of life. So we have a single sample size. All life that we know it has a universal common ancestor some 3.5 to 4.2 billion years ago. Every microbe that you see is your distant cousin. And so the people that talk about the n=1 problem say, hey, since we have one sample, really one origin, one separate origin, we're not justified in concluding whether any of the features of this life here as we know it would hold for other instances of life elsewhere in the universe. So here on the left is our most recent self-portrait, about 7 years old at this point. It's biologists organize descent in terms of like branching, how long these branches are. And we are this like tiny little branch here called the eukaryotes. The vast majority of life here is bacteria, whatever, but that is life as we know it here on Earth. Although interestingly, all of the things that have dots on them are creatures that we think exist that we've never seen before, which is kind of fun. There's so many that we can detect their DNA, but we have no idea what they look like. Entire chunks of diversity of life on Earth we've never seen. And that might just be because they're parasites, and every time we try to culture them, we don't take their food with them and they die. It might be a bunch of things. But some people say, hey, we have this sample size of life. It's just one thing. We can't make any conclusions about what life would be like elsewhere, whether it's little green men or some sort of something as we don't know it, life as we don't know it, maybe some technological AI, which I guess some of the people in the SETI, the Search for Extraterrestrial Intelligence community, now accept as the most plausible thing that we could actually run into, just because technology can probably outlive our meaty flesh bags that we take around with us. So, or whatnot. Okay, so single sample size, drawing inferences to life elsewhere in the universe. Really what's going on here argumentatively is something like this. We have a single example and it has lots of features. some of those features are essential to it being a kind of thing that it is. Some are accidental. This goes all the way back to Aristotle, right? So Aristotle says the redness of the apple is not essential to its appleness, it's something else. And so we think, well, we have a single case, and because it has so many properties, so many features, it's going to be really hard to tell the difference between the ones that matter for it being a member of the category that it's a member of and the ones that don't. We might be led astray as to what matters. Carol Cleland has one of the best ways, I think, of framing this problem. She talks about this hypothetical scenario where you are an alien biologist, and somehow a poacher gives you a zebra from Earth, right? And well, we're just going to name it Zed because I like giving animals names, and she didn't name it, so I might as well. And you're tasked as this alien biologist to draw conclusions about mammals as a whole based on this single zebra. So mammals can get really, really large. Blue whale is the largest creature that has ever lived. They can get really small. I think that little bottom right shoe creature is on the edge of a straw or something. They can fly, they can swim, they can build, they can do all sorts of things. They are a very diverse group. And she says, the kinds of conclusions that you would draw from Zed are not the things that would be true for most mammals. So you'd look at the stripes and be like, wow, stripes, that's a big deal. This zebra has like all of these stripes. Probably most mammals have stripes. And you'd look at the hooves and you'd be like, oh my God, there's hooves. Okay, probably those are important for it to run or whatever. It's multicellular, you'd be right on that one. Yeah, so many cells, it seems good. But the things that we tend to identify with mammalia, with this order that we are a part of, is giving live birth, which apparently has independently evolved some 79 times, and mammary glands, the feeding of young by liquid that you produce. And those would not be the features that you would infer from Zed. So with a single sample size, the problem goes, you can't draw inferences to the things that matter about the category that object belongs to. Here's another self-portrait of life on this planet. It is a measure of how far into various extremes life has explored in terms of temperature, acidity, salinity, pressure, that kind of thing. And as you'll see, like, these are weird shapes. I don't know what shape I would have expected, but these are weird shapes. We've explored some combinations, but not others. And you can imagine starting the tape of life over again, we would have explored others, or life elsewhere that had different pressures and temperatures might look completely different. And so Carol, when she's developing the n=1 problem, says, we know that life on Earth is not representative. We're weird in a lot of ways. So there's a couple of assumptions here, and I think I'm going to challenge all of them. I challenged the first one in a paper that I published, a chapter I published maybe 8 years ago at this point, that there's only one relevant class to which any sample belongs. Here talking about life. But the other two I'm going to develop here today. And so I'm going to have one slide on the first one. The other two will take up the rest of the talk, about whether we would recognize new cases as being of the same kind, and the assumption that we have this category that's held fixed, but the properties have still to be determined. I think that they are both idealizations and quite false. Okay, so just a footnote reference to a book that a chapter that I published on this book, The Impact of Discovering Life Beyond Earth, edited by Steve Dick in 2015. I argued that this exact example just shows that the inferences that we would draw from a zebra, we don't get to choose what the inference attaches to. She sets up the problem in saying that we have this single sample size of life, a zebra. Tell me about mammals. But zebras are members of lots of different groups, lots of different sets. They are camouflaged creatures. They are multicellular. They're bilateral. They're herbivores or ungulates. You can fit them into all sorts of different categories. And some of the inferences that you would draw from Z would apply to a variety of categories, not necessarily mammals. I think that's what sets the problem so thornily. But now I want to develop this new problem, which I think is more interesting and probably is a superset, encapsulates the old problem in a certain way. So roughly the problem, I want to spell it out here. Life on Earth belongs to and provides equivalent evidence for an indefinite number of broader categories. None of these categories are non-controversially equivalent to the life category itself. I'm modeling this off the this problem that philosophers of science might know, the new riddle of induction by Nelson Goodman. Let me just quickly tell you how that argument goes. Say you are measuring birds in a field or something, and at time 1 you measure 1 bird, at time 2 you measure 2 birds, time 3. You can keep going up until whatever timestamp you want, but you measure 13 at a certain point. And so the question is, how do we choose which inference is correct? Is it you infer that the next observation is going to be a continuing increase? It's going to continue to be less than 14. It's going to go back to an average, or you could literally make up an infinite number of mathematically consistent observations that the next thing could be. It's not a problem for most of us because we don't hop to new environments. We don't go and put ourselves in situations where we could be led astray so wildly. But if we're talking about life out there, if we're talking about things that we have not seen and don't even know how to see, I think the problem gets much harder. So we have life here on Earth. Some people look at it and they're very impressed by the behavior. And some of those people might think robots or clouds get to be alive in that sense. Some people are impressed by the evolution that life on Earth has gone through. We've evolved some subtle complexity. We've been able to adapt to countless environments. There's very few places on this planet where we have not found life. People have argued that some parts of the Atacama Desert don't have examples of life, but there's still like apparently there's viruses all across them that we just haven't discovered. Anyway, so evolution is really impressive. That's the thing that people point to, and they think, oh, whenever you see evolution, that's going to be life. Some people say, oh no, it's information that's the issue. We figured out some complex way of continuing information from one time to another. Your genetic code is a bunch of molecules that code for bigger macromolecules, and you've got your genetic code from your parents, and we figured out a way of copying that in such a way that we can call it information, and that's what life is. It's a certain kind of information, and so life is everywhere that there's information. Or you might think, well, maybe it's metabolism. That's the thing that matters. It's the ability to process energy in a certain way. There's a bit of circularity in what metabolism is. We define it in terms of metabolism is the kind of processing of information that life does, which if you try to come up with ways to carve out all and only the things that life does, that are metabolism, you get this really weird motley division, which it might actually speak more to how you divide reality than how the reality itself is divided. So all of these and more, people have made the arguments that this is what life is. There's been these debates over what kind of a category life is. And I go back to this self-portrait that we have of life as we see it. And I think back to Carol, I've heard her say this a number of times. We know life on Earth is not representative, but of what? Right? It's not representative of life as a whole, kind of presupposes that we have a life category that we've all agreed to. And that, I think, is the exact issue that we're wrestling about. It might be representative of a lot of things. Life on Earth might be perfectly representative of like evolving beings or informationally complex biochemistry, that kind of thing. But whether that gets to count as life is its own problem. So the old problem, we didn't know which properties were essential to life. I think there's still a little bit of a hangover of Aristotle here. We're still dividing the world in the ways the ancient Greeks thought to divide the world. The new problem, I think, is we know life on Earth has many properties, and that these properties are essential to many categories. But which, if any of them, gets to be the life category? I have solutions here, but first I want to talk about the kinds of evidence we're likely to see. And Kelly actually foreshadowed this quite nicely in his talk. He said maybe there's 4 possibilities. We don't discover anything. We discover muck. We discover, I'm going to carve it out slightly differently, but imagine we make discoveries and very few people agree, or we discover some muck that a few experts think is life, or we discover something and it like bunks us over the head and we're like, oh my God, that's totally life. I'm going to take each of these in turn. I think they reveal different issues. So the first, where very few people agree, I'm thinking here of the discovery of phosphine gas on Venus. I'm thinking about the discovery of methane on Mars, the discovery of, I don't know, a bunch of these things that we've figured out exist, did elsewhere, and people are excited for a little bit, and then they move on, right? We thought that there were fossilized bacteria in Martian meteorites in the mid-1990s, and then people were convinced that the fossils were too small relative to the biochemistry that we know. So it couldn't be life, at least not as we know it, and we dismissed it. The fossils were smaller than ribosomes. If you know any biology, that would be an issue. So that's one possibility. I think the most interesting possibility is that a situation in which some experts agree. And I think this reveals the heart of the matter. For any evidence that fits some but not all conceptions of life, you can imagine competent, well-meaning scientists still asking the question, but is it life? It's an open question. Every time we find muck and somebody looks at it and says, oh, cool, it's like got some proto-metabolism. But is that life? Is it though? We find a thing that seems to evolve over time. We find information complexity. We find lifelike behavior, and somebody showing up and saying, well, it fits some of the things that we think are interesting about life, but not all of them. That, I think, is going to be the heart of the matter. Any possible evidence begs the question, the philosophical term for when you assume that you are correct and your opponent is wrong, or at least assume that the thing you're arguing against is wrong, against posited essential features of life. If I discover muck and I say, oh my God, I found life, and you say, no, you didn't, I'm begging the question against you by saying that it is a sample of life. I'm presupposing that your category doesn't fit. Now, we're going to go a couple of steps beyond that in the next couple of slides. So I don't want you to think that that's exhausts the discussion that's going to happen. But if somebody radically disagrees with you, it's hard to even imagine how you can get consensus unless you come across a situation in which everybody agrees. You go out and like something bunks you over the head. You find Superman, you find Spock, you find a creature that is so obviously like life on Earth that it fits everybody's category. I think in this situation, if everybody agrees, weirdly, it actually doesn't decide between any of these competing views, right? If it's too similar and everybody counts it, we don't actually get to solve the debate about what the category itself is. It might reveal some interesting features about the nature of life, the nature of convergence, evolution, that kind of thing, but it won't tell us how does it resolve this category dispute. All right, so how do we solve it? Maybe case 3 happens all the time. Maybe we keep running into evolving creatures. We keep running into things, and everybody's just like, oh my God, well, I mean, there's no middle ground cases, so you don't have to worry about it. The gulf between pigeons and rocks and Martian creatures and non-living things is so obvious that we can just draw that hard line. Cool, we never have to solve this issue. There's a stable cluster of properties. Maybe we all just vote. That's a possibility. We'll get together, cast our vote. This is what I want life to be. This is the operational criteria that we're going to take to Mars. Cool. Or we could just murk everybody that disagrees with us. That's my preferred outcome, but I don't like to, or I didn't want to advocate it before tenure. So, now that we can just make everybody that disagrees with us mysteriously vanish. Cool. Those are, I think, the 3 possibilities of how to come to a consensus on this issue. But I want to focus on the first one because that's where I think a lot of people are going to be. That's what we hope we find. So I want to focus on that for the remainder of the talk. We'll talk about kinds. I'm going to try to get you to agree with a fairly controversial view in the next couple of slides. And it starts with this observation that what's going on when I point at something and I say that is life, and when John points at something and says that is life, and when Matt points at something and says that is life, or when Kelly and whoever, sorry, I'm just looking at the images I can see, is that there's reference slippage. I might be pointing at a creature and think that the thing that matters is its complexity. You might be pointing at it and think about its evolutionary history, that kind of thing. I actually think that maybe this happens with most concepts. Right? We have these debates about what we are referring to. And in fact, maybe most of our discussion is just clarifying concepts. So the prime case, the ideal case is supposed to be something like an element in the periodic table. Maybe games, maybe life, maybe, Carlos's favorite objects are just, maybe there's no natural divisions that we can find, but in the periodic table, there is something that shows that reality is broken into some natural kinds of some sort, and hopefully life will turn out to be like that. So let's talk about the periodic table. You think about gold, right? We'll talk about gold. It's a valuable yellow metal. The ancients knew about that. Has an atomic number of 79. They did not know about that. We think gold is so impressive. We always use it as this prime example of a natural kind. It's not a property cluster of something that's just like is defined by a couple of properties like red objects. It's not a conventional kind like games. It's not even an arbitrary grouping like ships and shoes and sealing wax and cabbages and kings, which are only grouped together because Lewis Carroll put them together in a poem, right? I like to think about this as in terms of how you would explain it to aliens. We think natural kinds of things are the things that aliens already understand. We point to gold and they'd have a different word for it, but they get it. Property clusters, we would just explain the property thing that they share, and they would understand how to differentiate things that belong to red objects and things that don't. Even if they couldn't see red, they could figure out the wavelengths. Conventional kinds, you basically have to teach a creature what a game is for them to separate games. You have to teach them some aspect of color. And there's nothing that unifies arbitrary groupings. So periodic table is supposed to be this prime example the prime example of what gets to be reality. And then you think back to the ancients knew about gold. They weren't surprised about gold. They knew that it was a yellowish, malleable metal. It was associated with some types of rocks. It was found in veins or deposits. It was valuable. We traded it. And now we have this other concept, this atomic gold concept. And we describe a lot of properties of chemistry and say that is gold. And so you can ask this question about whether folk gold is equal to atomic gold. Is it atomic gold? Did we discover some necessary feature of reality? Or did we just buy the chemist's propaganda? We had a concept, and now we had a folk concept, and now we have a precise scientific concept. And because it was so useful, we gave up the folk concept, despite the fact that I've never counted the protons in any gold that I've ever seen. I want to argue, and this is super controversial, so I'd love if people push back on this. I think that essences are posits. They are things that they are theoretical organizations of reality. And we have this periodic table. But you know what else happens to atoms is they have ions and isotopes, and they go through various quantum mechanical processes. And each of those is also a thing that happens out in nature. We just decided that the thing that mattered to us was the number of protons because it was most explanatory for the things that we dealt with. We got to keep enough of the features of folk gold in our concept of atomic gold, enough of the features of folk water with our concept of H2O. But if you've ever tried drinking distilled water, just pure H2O, you are dead and not listening to me. So there is other stuff in water that makes it the kind of thing that brings nutrition to your body. And that's not H2O. There's other stuff out in nature that fits our concepts. It's even weirder when you try to like squish the periodic table. There's this cool paper, the squashed periodic table. It turns out that even the properties, like the fundamental atomic properties, changed at different pressures. So even these things that we thought that were essential were everywhere, change depending on how we measure them. So like, okay. So where are we? We are in a situation where our best case scenario was a periodic table. I don't even want to go that far, but even if we could figure out life was like a periodic table, that'd be happy enough. The chemists did win the debate. They did win. They convinced everybody that gold was just having 79 protons, and the debate was settled. Like the people that say, actually, you're not capturing a lot of our daily use, they don't matter because we have a technical, precise scientific concept. But I think the evidence is already in biology. When we talk about things like the RNA world and viruses and synthetic biology and prions and artificial life, and even like trying to establish criteria for searching for life elsewhere, that there's so many problem cases that the periodic table is way beyond what we could imagine. We're never going to get that kind of clarity in biology that we got in chemistry. Yeah, I'm not even that convinced about chemistry. So there's so many problem cases that I think we just need to give up on going out into space and having something thwack us over the head and tell us that is life. And the reason I think that we should give up on that is because we've been thwacked over the head enough times and people have still asked, but is it life? In 1975, we sent some probes to Mars that did life detection experiments. 3 confirmed that there was life. One said there wasn't, one said that there was life. 3 said that there wasn't. We couldn't find a way to connect the dots to draw a line from all of those. So we decided it was inconclusive. All of the controversial cases about whether this gets to be a fossilized microbe or not were inconclusive. We were expecting life to be as obvious as as clearly divided from non-life as stuff in the periodic table is from each other, we're not going to find that. So we have only two options. Well, I know where I'm voting. All right, let me wrap this up. I have 1 minute to wrap it up, which is good because this is the last slide. In conclusion, there are an indefinite number of answers over what the category life even is. Any evidence can speak to an indefinite number of categories. What is life is a decision. It is not a discovery. And it's a decision that we should probably do before we run into more of these problem cases like we did in the 70s and in the 90s and whatnot. We should agree on the features that we think are most interesting and most important of life, and make that our category. And with that, I'd like to thank you, and I'll take any questions you might have.
All right, thank you, Carlos. And if you have any questions, put it in the chat and we'll try to get to you. Once again, if you raise your hand, then we'll also call on you if you have any questions. All right, so thanks for that interesting talk, and let's have Garrett Merriam give the first question.
Thank you, Carlos. Yeah, really interesting talk. I particularly appreciate both the visuals. I thought those worked really well. I know you can put a lot of effort into that. It's nice to get them acknowledged. And I'm also glad, or at least I hope, that a lot of my philosophy of science students are here because you touched on a lot of stuff that we've covered this semester. So I look forward to hopefully having some conversations with them about your talk in the future. I have a couple of questions, but I think I'm going to start at least with the one which might hit closest to what is perhaps the most novel part of your argument, and that is I'm very sympathetic to your sort of pragmatist approach to the question. I wonder if maybe it just might not make sense to take it a step further. After listening to your presentation, I started thinking that the question "what is life" kind of reminds me of that age-old question in aesthetics: what is art? And my response to that is that at a certain point, especially after you get through 20th century art, you realize the category just doesn't really make sense anymore. It's just sort of been beaten to death. So why not just give up on the question of life at all? If what we can agree on is something like, well, this thing has proto-metabolism, this thing has that and the other. If we got solid agreement on what qualifies as these things, then why don't we just have a conversation about those things, and we can just completely drop the question, is it life? And we don't have to worry about the sort of, quasi-political process of voting on what counts. We just abandon the category as no longer relevant and go off the stuff which we have solid scientific basis and agreement upon which to apply as we go out into the universe.
Awesome. Love this question. Why not just be an eliminativist of some variety, right? I have been very tempted by that in the past, and in print I've argued things that are very close to that. And I think I eventually, maybe in my heart of hearts, I think that there's this fundamental miscommunication that's going on, and it's not problematic in biology, but it does get problematic when you deal with the boundaries of biology, like it does with the boundaries of art. And so in those cases, maybe we should just pay attention to the features we care about rather than this like made up arbitrary grouping. The reason I don't go that far anymore is because people still use the word life. They still use the concept life. I can't, for the life of me, get people to stop using it. and I've tried. I really have made this case. I think that that it creates more problems than it resolves. The concept of conceptual slippage, right, where you and I have slightly different concepts, and nevertheless, most of the time we could communicate, even if what you mean by bachelor is different than what I mean by bachelor. That works in a lot of cases. I think it stops working when we talk about the stuff that I'm talking about. It becomes problematic, and so because I can't get rid of it, the next best thing is just to get people to agree and just show them why agreement is not something that's going to come in the future with new evidence. The evidence that they are going to encounter is itself going to require them to come to an agreement, right? So I think a lot of people think about future evidence, the way I think about like when I'm finally going to get back in shape and get all my habits, future Carlos is going to be different than current Carlos. Future evidence is going to be different than current evidence. It's not. Right? So to answer your question, I want to stop using the term. I want people to stop using the term. I can't get them to. This is the next best thing.
Okay, we have a question from a student here, Jacob, asking, well, what if we kind of like explored more outer space and ran into more alien life, or ran into alien life, things like that, or what we might perceive to be alien life, and we just learn more, and all of a sudden we find that there are these essential features, right? So don't we just need to do more gathering of data? And well, we just have examples of life here on Earth, and we can't come up with essential features. But what if we could do that? This is something like that happens with gathering evidence about extraterrestrial life.
Cool. I definitely think we should go gather more evidence, but that evidence isn't going to be labeled with this is the essential feature you were looking for, right? It's not like we're going to get God from above is going to tell us these are the categories that matter. These are the things that matter to make this a member of that category or whatnot. We definitely should go out and gather, and it's going to turn out that we haven't considered the right sort of reactions, right? There's this entire movement in astrobiology, the slow chemistry movement, that argues that all of our work in chemistry has focused on what can be done in a graduate student's career or a postdoc. And if there are chemical reactions that take longer than 5 or 10 years, we might just not know about them. And some reactions might take millions of years. Also, messy chemistry is another approach. So yeah, we should definitely go out and explore all of the natural experiments that have been done. But it's not the case that once we gather that data, the solution is going to be resolved for us. It's just going to get more complicated in maybe similar, but maybe slightly different ways than we expected. We're still going to have to make that decision. Oh, you're muted, sorry.
We have another question in regards to, it's kind of a sociological question. Is there any kind of scientific consensus among people, astrobiologists and NASA scientists, as far as what their definition of life is? So you might say there really is no kind of objective set definition, but is there some kind of consensus in the astrobiology community?
There is actually. It's just a bad one. So the accepted definition now, that the NASA definition of life was usually attributed to Jerry Joyce in 1996, although he says that he didn't come up with it. It was a group discussion. It's a type of biochemistry able to engage in Darwinian evolution. I think the reason it's a bad definition is that it works for like some conceptual stuff here on Earth. It stops working when we start looking to categorize new kinds of evidence. So it's useful in saying, hey, we've just decided by stipulation the philosophical part of this argument. But then you have to go that next step and realize you're still going to have to interpret new evidence. And we just haven't been forced to reckon with how imprecise and non-useful that definition is. Thank you. That was a good question.
Okay, and so another question is, so it sounds like you want to say that, your approach to defining life, is that somewhat along the lines of like a Wittgenstein like language game? They're just different communities that create different definitions of life. And then does this have broader implications in philosophy of science as far as the objectivity of science? So whether there is extraterrestrial life, that's relative to one language game on how you define what life is. And for another people in this other game, it's false. It could be true for one group and it's false for another. Biological questions about life, like explaining how life arose on Earth, which biologists are interested in, that itself is just relative to how you define life. And we can do that, for physics, for planets, how you define planets. Pluto's a planet, maybe it's not. Well, it's true relative to one group. It's not true relative to a different group that defines planets in different ways.
Awesome. Man, it's been a hot second since we've talked. But yeah, no, weirdly, I think I'm coming more to your views on these issues, which is devastating for me. I do think that there is sort of a Wittgensteinian language game going on. I might pause and reassess for a second about whether that says anything deeper about science. I'm certain it does. I just don't know if I want to go all the way in so far as saying that what's going on with Pluto is another example of this. I think about when you talk to the astronomy community, they're furious about the Pluto decision, right? Because it's the International Astronomical Association that decided in 2006 that Pluto doesn't get to be a planet. The people that study planets, planetary scientists, were not at the meeting. So it's just like an entire other field saying, oh, Pluto doesn't get to be a planet because there's other things that are like it, and we don't want to make them planets. The planetary scientists say, no, we should have just added all of the planets. We should have added all of the ones that we had discovered that were bigger than Pluto. We shouldn't have made up these new criteria and carved out Pluto and created this dwarf planet. And so maybe I do think that kind of illustrates the same sort of thing that's going on. We have this scientific concept, and it's clear up until we run into boundary cases. And then, as in the case of Pluto, we had to like reassess the scientific concept. I think it's extra hard in situations where there is a cultural concept and a scientific concept. So the term planet used to mean the 5 observable stars, or sorry, 5 observable moving stars plus the sun and the moon, right? There were 7 planets. And then we discovered, Herschel in the 1700s discovered Uranus, and then in the 1800s we discovered Neptune, and we have to like reassess with whether the sun and the moon gets to continue being planets. Actually, the historiography is a little bit off because we had to reassess what planets were before that. And so I do think that would I say that it's relative? I think that it is more relative than some scientists are willing to admit, and some philosophers of science are willing to admit. We think that nature is just divided in these ways, these natural ways, and we are discovering them. We're not bringing stuff to the table. But in fact, there's so many divisions out in nature that we can't escape our contribution to this, to categorizing planets or life or whatnot. So I hope, I don't know if that answers your question. I hope it does in some way.
Okay. Yeah, maybe we can talk about it later.
Sure.
We have kind of a clarification question. Would your views be to define life, but not further explore it further in space?
Cool. Good. I think we need to continue exploring. And now that the James Webb Space Telescope is about to unfurl, I think it's going to unfurl fully in June or July, we're going to be able to image the atmosphere of various planets outside of our solar system. So we're going to be able to like figure out if they have chemical reactions that we would not expect absent life. I think we should continue to do that, and that'll be fascinating and interesting. I just think that there will not be a situation in which the answers will hit us over the head and we will come to a consensus. So I think we need to have a good definition of life that's a little bit stronger than the NASA definition of life. And if we need to reassess in the future, that's fine. Just realize that it says more about us than it says about reality. These terms, these concepts reflect more the psychological and cultural features of scientists and philosophers than they do about reality out there. I hope that clarifies that.
Okay, and we have looks to be our final question coming from Garrett.
Okay, thanks again, Carlos. Like I said, I'm very sympathetic to your overall perspective, but I want to give you a little pushback because I'm not sure how I would respond to the question. So maybe you can do a better job for me. So I'm going to stipulate that you're right that more evidence, new evidence, isn't going to solve the problem. Again, that's age-old philosophy of science issue, right? But the usual pairing with that is when evidence can't help, what we need is better theory. So I want to go back to your example of the or maybe you're borrowing from someone else, the zebra example. I think it's certainly true that if an alien biologist only had the zebra, of course they would not be able to make very good inferences about what else they're going to find. But they don't just have the zebra. Presumably, they're going to both know the general principles of evolutionary biology and have some information about the environment in which the zebra evolved. They may even have a grand scoping picture of the planet. So there's going to be oceans, there's going to be mountains, there's going to be forests, and you see what you can see about the zebra and say, okay, let's give couple of 100 million years of evolution on this environment. What kind of diversity and they will be able to make reasonable extrapolations. Of course, they're not going to be able to nail everything. They're going to be wrong about a lot, but they're also going to be right about a hell of a lot more if they had the zebra alone. So applying this to the broader question, while, again, if all we were going on is, the life as we know it, then yeah, that's a problem. But presumably we're going to get better theory about, not just evolution, but, how life could evolve in space, and astrobiology as a theoretical field will presumably grow and get better. And maybe that better theory will be able to fill in a lot of the gaps where the simply having more data will fail us.
Awesome. I think that's completely right. In fact, I'm currently working on this book, my post-tenure project, which is also my pre-assistant professor project, but I'm finally getting back to it. This book, Universal Biology. I think that theory can get us very far. And when I look at a zebra, it's not just that I am embedding it into a bunch of theories. There's also lots of different ways of parsing the evidence I do have, right? If I'm attending to the stripes or the hooves or the cellular makeup or the behavior, like those all give me different kinds of evidence that I can incorporate into theories. And I do think that I think evolutionary theory is powerful and strong and properly understood ought to be conceived of as universal, and same with a bunch of other theories in biology. I think we run into problems because we often think about those theories as applying in limited domains, and we don't consider the fact that even across life on Earth, evolution goes at different rates and in different ways. So when you are faced with limited data, as in the zebra case, you might still have a question as to what aspect of the theory might fit to it, how you might best interpret the theory, and you might be defeasibly incorrect, or defeasibly correct, I guess is the best way to put that. But I think that there's lots of inferences that we can draw now about the nature of life. We don't have a dearth of information. Even if we have a single sample size of life here on Earth, it's evolved a lot. We've done a lot of stuff in labs. We've come up with ways of synthesizing essentially new microbes. We can incorporate our theoretical understanding in ways to make sense of how the diversity and extent of life here on Earth. And we know enough about the raw materials that we would expect to have. So, so we're actually on pretty good ground in a lot of ways. We're just not at the answer that everybody wants. Everybody wants to just be like given these little green men. Does that answer, or at least attempt to answer your question?
It gets in the same general direction, but yeah, I wish we could push it further, but we are at time, so we'll have to leave it at that.
Cool. Appreciate it.
All right. Thank you, Carlos, for giving that great talk.
Thank you. I appreciate it.
And before we depart, I just want to give a reminder that we are going another day tomorrow. We're going to have Professor Matt McCormick and Professor Di Silvestro, as well as myself, kind of talking and debating various issues in philosophy of astrobiology, such as whether we should terraform Mars or not, what implications the finding of extraterrestrial intelligent alien life would have for the existence of God, whether, as well as whether or not we can kind of how we can determine whether alien life is conscious or not. What's the moral status of aliens? Do they have full moral rights like humans? Maybe more, maybe less. So we'll be debating a variety of different issues, and we hope to see you tomorrow. So Garrett, did you have anything further to say?
Yeah, just one quick reminder that it is a different Zoom link than for today's talk. So don't come back to the same link that brought you here. Check the schedule. There's a separate link for tomorrow's talk.
All right. So hopefully we will see you tomorrow. Goodbye.